Hi, this is Dr. Baby Shalini, Associate Professor, Department of ECE, Rohini College of Engineering and Technology. In this video lecture, we are going to see about the general feedback structure. So first we have to know what is a feedback. A feedback is nothing but a portion of output signal is fed back and it is given to the input, which is used to control the performance of the circuits. So there are two types of feedbacks available, positive feedback and negative feedback. So among these two, the positive feedback is better to use. Now come to the general feedback structure. So the general feedback structure consists of a signal source in series with a resistance Rs, and next to that we are having a mixer network. The mixer network is used for mixing the feedback signal with the input signal. And there are two types of mixing available. They are series mixing and shunt mixing. And next to mixer, we are having the basic amplifier, which is nothing but either a transistor or a operational amplifier. And the gain of the amplifier is represented as letter A. And next to the amplifier, we are having sampling network. So depending upon the type of sampling, there are two types available. They are shunt sampling and series sampling. Next to the sampling network, we are having the load resistance RL. So next, let us see about how the mixing network works. So there are various types of mixing available. So look at figure A and B, which shows a simple and very common series input and shunt input connections. So first look at figure A, which represents a series connection. So the feedback network beta is connected in series with respect to the input. And next come to figure B, which shows the shunt connection in which the feedback network beta is connected in parallel with the input source Vs. And then figure C and D shows the mixing network which consists of a single transistor, and figure D consists of a mixing network with the differential transistors. So next we have to see about the feedback network. Actually, the feedback network consists of several passive components like resistors, capacitors and inductors. Most commonly, only resistive configuration is used. Next, let's see about sampling network. There are two types of sampling available. They are voltage sampling and current sampling. So figure A represents the voltage sampling, so in which from the load or from the output, the feedback connection is taken as a shunt connection. If we are taking the connection like this, then it is called as voltage sampling. And next come to figure B, in which the portion of output is fed back by the feedback network as a series connection. And since here series connection is used, it is called as current sampling. So next let's see about what is transfer ratio or gain of the amplifier. So at the center block we are having a transfer gain A of the amplifier, which represents the ratio of output signal to input signal. So for an ideal amplifier, there are four types of gains available. They are voltage gain, current gain, trans resistance and trans conductance. So voltage gain is nothing but the ratio of output voltage to input voltage, and it is commonly represented by AV. And the next is current gain. So it is the ratio of output current to input current, and it is represented by the gain AI. And the next is transconductance. It is generally represented by letter GM, and as the name indicates, conductance is the ratio of output current to input voltage. And the last parameter is trans resistance, which is represented as letter RM, and which is nothing but the ratio of output voltage to input current. So even though GM and RM are defined as the ratio of two signals, they are not proper gains and they are not used for representing amplification. So only current gain and voltage gain are used to represent amplification factor. Thank you.